so I am Zvi Shalem from Israel. And so the idea is to use technology, in this case, apps, to empower the teacher, which means the teacher, these are apps that the teacher will use in class. It's not something that she just sends off to the students and analyzes the results, something in class. So I'm going to give you a background about where I'm from, what I'm doing, and then we'll see the pedagogical ideas. And maybe it will be connected to quantum physics, I don't know. That's up to you. I didn't think about that much. All right, so education and main projects. Okay, so I did just the first degree in physics. I started doing a graduate degree in education, but it was wildly irrelevant, so I stopped.
I think if you put it in presentation mode, it will be even better. Because I think, well, it's okay.
No, it's not in PowerPoint really. It's like something exported by PowerPoint.
Okay.
Okay, so I've been working like for 16 years or so in the Israel Center for Excellence Through Education. The main project of this is the Israel Arts and Science Academy. It's a really top school in Israel. It also has a dormitory. You see, 25% of the graduates go to do a PhD. Very good school. But I don't work at the school. I got to work there at the Excellence 2000 program. And it started as an outreach program because we wanted to get as many students as we could from all around the country. So created this Excellence 2000 program. It started really with extracurricular activities, just to develop the mind, all kinds of logic, riddles, whatever. But not a riddle that you just give to the student and it's like an insight. So like, I don't know, 5% of the students solve and the rest don't. It's something that you always have, that everybody can start working on it. It's something that everybody will start and then gradually they will discover stuff. So that's the Excellence 2000 program. Eventually it got its another life on its own, became an independent program. And now it's used in Singapore. All the excelling students in Singapore in math elementary school use Excellence 2000. I mean, it's a very, very powerful program. I'm going to just give a little example from that. That's not the focus now. This is just, it's not acts. It's just really good activities. Okay. At a certain stage, I saw different apps. I just encountered different educational apps. And I didn't like them that much. I saw lots of graphics. I mean, I saw some app from an American university, actually, where like very nice graphics and you're in the ocean and you get to some castle and you go to the castle and you see a little box or a treasured box and you click it and you just get a regular math problem. What are you doing for all the trouble? Okay, so you know how to pay graphics, okay. And they really also know how to pay people to do data analysis, to take lots of what every student did, so they know how to do that. With graphics, I can't compete with anybody in graphics. With data analysis, I'm not an expert on that, but I do have a lot of experience with with math education. So I actually learned how to program on my own, created lots of apps in Flash, I then created all of them again because Flash died. And so I'm gonna talk. You're gonna see what ideas are embedded in the stuff I created. I also this is my friend Gali Shimoni. He hired me for Excellence 2000 and is working with me on this stuff. Very, very, very good guy to work with. Working with him for years, and he's also my colleague for inventing games. Okay, so these are physical games you can buy in stores or in Amazon and stuff. Not connected to our work at the Israel Center for Excellence Through Education, but we know how to invent games. We know how to invent stuff that people like to play. Swish is really good on Amazon. This Flipolo is in like tons of versions. Here I got the Harry Potter version. So, okay. Now our pedagogical approach. So here the next slide won't surprise you too much, okay? So concepts associated with a fantastic lesson. right? Interesting, has to do with discovery, engaging. We want dialogue between the students and groups with the teacher to express their ideas. They have to want them to feel it's relevant for them. Yeah. So nothing surprising here, right? But that's what we believe in. But the thing is, the tricky part is to create such a lesson. Okay, so we discovered having an interesting lesson is good. Okay, so how do you make an interesting lesson in a certain topic, in adding fractions or whatever? How do you make it interesting? And of course, you have to deliver the lesson, right? That's also not so easy. Okay, so there isn't any silver bullet. You can't say, this is how you create fantastic math education, just do that. No, doesn't work that way. Actually, but we have this feeling all creeping around, the idea that there's this technique that if you do it, you get great lessons. As a kind of a little protest, Gali and I, in our office, we just put like a button there on the door, and the button says pedagogical button. Click here and get a special lesson. I get a lesson. And for some reason, I don't know how, that icky button stayed there for like 10 years. Any case, no silver bullet, which just means there's a lot of work, no shortcuts. For every lesson, you have to work a lot. And we had an opportunity to do that, which was really good. Okay, so details matter. Working with Gali, he always thinks, okay, nice idea. What would happen in the class? What does the teacher explain? When does he let the student start to work? What does he do with this? So a lot of details, a lot of work, but that's what we have to do. And like in Israel, in the Ministry of Education, we really are like the gold standard of like good stuff. Okay. I just want to say one thing about the relevant, because here our perspective might diverge a little bit from common knowledge. Okay, so relevant can be related to everyday life, but not necessarily. Something can feel relevant and interesting even if it has nothing to do with ordinary life or regular life. And relevant doesn't mean relating to a political agenda, like Agenda 23. Okay, so that's not what we mean when we say relevant. And I'll give an example. So this is an activity. I happened to be in the class when when Gali was delivering this to ninth graders as a pilot program. So it's called Search and Rescue in the Sea of Numbers. So you see, this is not a very realistic sea, right? No ships. It's completely imaginary, of course. And the basic idea, you have this board and you have ships, and if a ship is in distress, it sends as a signal the sum of its numbers. So you see 1 to 8 sends 11, okay? And the task, what the students have to find out is they get a certain number and they have to figure out what ship it was and where the ship is. Okay, so that's the kind of a riddle. Not connected to reality, not connected to politics, nothing. It's like just a riddle. But during the lesson that I happened to be there, that was nice. One of the students in ninth grade raised her hand and said this. One second. Why did she say that? Okay, she said, I didn't know my teacher's X's had any use because it was a riddle that they wanted to solve and didn't look connected to anything, but it turns out that algebra really, really helps. If you decide, okay, let's call this x plus 1, this x plus 7, whatever, then it really, really helps. And she felt, wow, it has a use. So the student in ninth grade, for the first time, she started learning algebra in seventh grade. She felt, oh, wow, the x's helped me do something. Because until then, how did she approach algebra? Well, the teacher says, okay, I have this line with numbers and symbols. I do these operations and I find what x is. So it's just like technical stuff. And here, the x's help solve something. So this means it's relevant. This means we created something that the student wanted to solve, and that's why it was relevant, because it captured the imagination for whatever reason. The story, the kind of question. Okay. Okay, now I'm gonna give a little example. Do you see the pattern here? What's the pattern? What's the rule for this this thing here? See the kind of what?
I don't know.
Okay. Starts with the P. Oh. Palindrome. You know what a palindrome is?
If you spell it backwards, it's still the same.
Yeah. Palindrome. It also it's a yeah. Was it a cat I saw? Is the palindrome because you can do it backwards. There are also palindrome numbers. Okay, so palindrome number 1551. Palindrome. Everything, every row and column is a palindrome.
Well, 8868.
Oh, I made a mistake. Oh, so I filled it in. I'm sorry. Okay, so you got it, but you made but okay, so it's my fault. I had to put an 8 here. Yeah. All right. So it's almost a palindrome. My mistake. Okay. So we created a lesson that's like a preparation for algebra. It's a different one. And the goal was to make algebra feel relevant and discovered in a certain way. So this is an app. I created this in an app, but the app is not the relevant thing. It's just the activity. Sorry, this is in Hebrew in this regard. So the task here is for the students to fill in the palindrome. So see, it's pretty. If the 6 here has to be there, so the students can fill it out. So the 6 here it has to be here, right? So just straightforward, fill it out, no problem. Okay. Next page. Okay. Here we have another kind of clue, which is the sum in this row. Okay. So the students start solving. Okay, this is 4. This is 4. This is 4. This is also 4. This is 2. And how do we figure this out? Well, it's 8, we need a 7, so we get the 7. All right, okay. Now this starts to become a little bit interesting. Okay, so now where do we start? Okay, so let's say a student starts and puts 6 here. Okay, now let's see what happens. He has the 6 here, the 6 here, the 6 here, and also the 6 has to go here. Okay, so it doesn't work. But it doesn't work. What did the student discover? Even if it didn't work, what did he discover? That these are all the same number. Okay. What? Okay, the same number. So they did in the discussion after they tried to solve it. What we introduced is the idea of putting, let's say, we don't know what this is. Let's put a triangle. Okay, we don't know what this, but it's a triangle. We'll call it a triangle. So this will be a triangle, and this one, and this one, and this. Okay. So now, what did we do here? We created a situation where there's a problem, and algebra helps. I mean, we didn't call it algebra. We just said, okay, let's choose a triangle, and when you see that the dynamic makes sense, this logic makes sense. Okay. And over here, it's already tricky. There are 2 variables. So let's see how this goes. Let's say put a triangle here. Okay, so we have this here. If I make a mistake, tell me. Okay, so this goes here, this goes there, and this has to be this and that. Okay. Now now we don't have to. We're stuck. So we did the next variable. So we're already with 2 variables now. Okay, so 1, 2, and 3. Okay. So now we introduced algebra in such a way that it's not like, okay, listen, we have an x, stuff, it's from a very different direction. That's relevant, interesting, whatever, everything we wanted. And also, we also have an intuitive way to solve this. I mean, how do you think a student would solve this? So how would you like them to think about this question? Okay, so we did this. So what do we do now?
Well, convert it to equation.
Yeah. Imagine you don't know any equations. You don't know equations. Something intuitive. Because you're so used to equations. I mean, like, okay, 2x plus y, Okay, so as a student who doesn't know equations, you would ask if they don't get the idea, but they can get the idea, you would ask, okay, what's the difference between these 2 lines? Yeah. And how much of a difference did it make? 4, right? So that's how we know that this is 4. Because the simple operations of equations are really intuitive. It's not like something are not understandable. They are very understandable. Okay, so you put the 4 here, and you see, all of them turn into a 4. Okay, now these together have to be 10, so each one is 5, and then finish. Okay, so cute way to get algebra. This could work everywhere in the world, no problem, because it's a nice lesson, and everybody needs to learn algebra, and this is a nice way to introduce it. So that's the basic pedagogical approach. Of course, so there's no button you could click to get this kind of lesson, right? Because it comes from somewhere, palindrome, patterns, whatever. So that's why it's a lot of work. Okay, next. Okay, so now we're gonna go back to apps, and with the same goal to try to make lessons interesting, visual, whatever. Okay, so I'll give examples. Here I embedded, so these are all based on apps that I created. And I'm able to put lots of them together in the same sequence. So to see it's convenient. Okay, so let's say fractions. Okay, so I can fold this up. We don't need this stuff. Okay. All right, so we have this question, not difficult for you. So this app is very different than stuff you would just send a student, because the app won't tell you right, wrong, nothing, no clowns will jump up or anything like that. We have a question, and we want the students to think about it and visualize it in a certain way. So, of course, we can change the question in the app. But now, what this arrow does is gives us a visual representation of 2 and a 4th. Okay, so if we take out many of them, then many will come out. So it's because it's not a feedback thing. It's an aid for visualization and discussion. Okay, so how many do we need? We need 4. So this is the meaning of 4 times. So it's addition. So multiplication now is expressed. So so a teacher, if he just has a marker, he wouldn't do that. That's a lot of work. So the reason I created these apps, so I understood that they're useful, is that I'm thinking, all right, a teacher has a marker. With a marker, now there's lots of stuff you can't do. If I draw a circle, I can't move it, right? I really can't do a lot with it. And since I saw that in Israel, and I'm sure in the States, every school has a projector and can be used with you can put in visual tools or digital tools. Why wouldn't you do that? It just because it obviously makes it very visual and convenient. Okay, so think back elementary school. How do you want students to think about this now? What do you want them to do?
Sum the quarters.
What?
Sum the
Yeah.
quarters.
Right. So separate the wholes from the quarters. Okay. So we can simply separate. So this visual element, you can drag it from here, but if you take it from here, it just separates. So you have the idea of dragging, taking apart, and putting together. You can just put them back together. Okay. So now you have 4 times, which is 8 times 4 fourths, which is a whole. Okay, I can just put them together. So the thing is, if I try to show this to a programmer, it'll say, "Oh, that's easy." If I show it to a graphical designer, it'll say, "It's just simple circles. What are you doing?" But if you show it to a teacher, elementary teacher, it's like, "Wow, I can use that." Okay, so yeah, it's very, very simple, but it's good. And the idea is that the students, that this it's something that sticks in their head, because the idea is that it's not like okay, now they're going to start using this instead of thinking about it in their head. The idea this is like a bridge, and the next stage they have this in their imagination. Okay, there's a possibility here to duplicate a page. So, for example, here is the same question. Can you think about a different, interesting way to solve it, or something that's intuitive, or a different way of thinking about it? So I'll give a hint. Okay, visual hint. Okay, so do you see what I mean? Yeah. Okay. By the way, for my daughters, when I don't know, the third grade or fourth grade, when I ask them to do something, multiply something times 4, like I don't know, 7 times 4, and they have some difficulty, I always just do it with my hand. Okay, imagine each finger is 7, and so you have 7, 7, 7, 7, and together. So, because it's not only helps solve, it's also enriches the number sense, understanding what multiplying means. So, okay. And so with the app, you can show more than one way of solving a problem. So 4.5 and 4.5. This was used also in South Korea, and I was there and I gave a lecture to parents actually. And I showed a triangle and I said, okay, what's the area of the triangle? So a parent came and said, okay, here's the base times the height divided by 2. Area. And then I said, okay, do you have another way of solving it? And the parents started laughing. Because what do you mean another way? It's base times height divided by 2. Like, what are you doing? But one of the parents came with his kid who was in 3rd grade. And that kid didn't learn how to calculate the area of the triangle. So the kid came up and said, take this piece, put it there, and then you have a rectangle, and then I know. So that's very important. You really want that. You don't want people, we like math to develop thought. We don't want math to replace thought, or students or that think about it as 2 different things. There was a guy at my workplace who was doing a degree in economics, and he asked for some help. And I said, okay. And one of the questions, there were four factories, and each one had different parameters. How much each thing cost, how close it is or far away, whatever, all different parameters. And you have to figure out which is the best factory. And so I looked at the problem and I saw factory A was better than factory C in everything. So I told them, okay, well, factory C is not the best one because A is better than it in everything. So what did he asked me, wait. What equation did you use? Okay, that's bad. Okay, that means for him, math is just like an instruction book. Has nothing to do with thought. If an educational system creates people like that, no more math. You will have no more math next generation, because you want people to feel, to have all rich intuitions about what they're doing. You know, you have Waze in the States. You use Waze. How do you right? Or yeah.
Well, it's now bought and subsumed by Google Maps.
Okay, so Google Maps, right?
Yes.
So imagine going into a city where you kind of know where you're going and you're navigating and remembering and recognizing whatever, as opposed to using Google Maps. Google Maps, you can just disregard everything. Okay, so you don't want students thinking about math like Google Maps. Okay. Okay, so we have also more closed apps, something more buttony, you say that. Okay, so for students, you know what mistakes students sometimes make even with something like that? You know what they do? What do they do? Huh?
They add and put 2/6.
Yeah. They add 1 + 1, 3 + 3, 2. Yeah, it's very, very common mistake. But with the visual, when it's visual, they don't do that. Okay, so here you see the third. You go and do this stuff. Okay, so this has embedded questions. So these are pretty obvious, very easy. Every student will say, all right, got it. Okay, now next level. So we have the 2. So 2 is different than the 4. So we have a problem. So what you can do with this app is move this and you change the expansion. Okay, so it's very you see the student sees that the half stays the half, but you see the division changes, and you see the original problem and the equivalent question, and when you get to here, you see the button solve appears because the denominators are the same. Okay, so very, very intuitive. Okay, of course, in the third level, you have to do it with both of them. So here's another example. Okay, next. Okay. Sorry. Did the wrong next. I'm supposed to be inside the app. Okay. Okay, this is again the open app. This is one of the first one I did. And I mean, sometimes I invent something and I think it's special. This is like an invention, like, I mean, it has to exist. I mean, it doesn't make sense that it doesn't exist. So each kid gets a pizza. What do you do with the third one? You divide it into 3 and give each one a piece. Makes sense. This app needs to exist. I mean, for me, it seems obvious that, okay, this is trickier. Believe it or not, I mean, it's sure you understand because there was one extra pizza, then it's easy, okay. But when you have 2, I even used this with a kid who was like he wasn't a strong kid, but in sixth grade, we tried to divide each pizza into 4, it didn't work. We tried to 5, and yeah, so this can actually be challenging if it's a weak student, but with this app. It really helps all the students understand. It's not like one student gives a solution. You can really visualize and show the solution. And if you think about what's happening in class, then you could say, well, one of the students would be the aide for the teacher and do all this kind of work. Okay, here we have for decimals. So what's bigger, 0.3 or 0.27? So, some students think, well, 27 is bigger than 3, right? So here we have a visualization that's specifically tailored for decimal numbers. So I just click split, divides into 10, and then I color, and then we have 1, 2, 3. Okay, now let's split this one. Okay, color, and now we need to split the 10th into hundredths, and we color. Okay, so now it really makes stuff clear. It can really, really help. Now, teachers who start using this and get used to it, I mean, they don't teach without it. Okay, how do you read this number? How do you say this number?
0.27.
0.27, right. How's another way to say it? What you see here is actually, it's more like 0.27, because you see the 2 tenths and 7 hundredths. Okay, so but we can, if we split this and also these, now we see the 27. So this app also helps make sense of the 2.7 or 27, because 2.7 is actually more intuitive. I feel funny that I'm showing this to academics, but well, all right. Okay, this is another app. You see how I can create stuff. Okay, how many circles do you see? How many circles are there on the board?
70,
70. How did you do that?
21, and 28.
Oh, okay. 21, 21, 28. Okay. Can you think of another way to do it?
3 plus 3 plus 4 plus 7.
Right. Okay. So the first answer is 21, 21, 28. But we can give a hint here. Look. The same, you remember the fraction, you can take stuff apart? Same thing here. You can take it apart. Well, we can see here that we can take this apart, put them together. And then we see, well, 3 sevens and 3 sevens is 6 sevens. And 6 sevens and 4 sevens, that's 10 sevens. So makes it easier if you think about it in a different way. And you can also think about it like that. So again, so the visual really promotes the exact way of thinking that we want. So sometimes we worked hard just to get the simplest possible way to do stuff. Okay, this is more buttony, whether I don't know how to say it, because this is very flexible. You can just move stuff around. So when it throws stuff out, of the screen, I can say, okay, let's take 38. Take it out. How do you calculate this? So of course, then that would be the easiest way. Makes sense. Okay, and here, this is more structured. Okay, so here, what do? We can, of course, we can change the numbers, different questions. So we see how, so here we have the algorithm, and here's the visual. So put them together. We do that quite a lot. So the 12 is 10 and 2. And here we do this. And now we can click distribute, and look what happens. Oh, see? Blocks go, and we see what happened. What number was multiplied by what number. So it's less flexible, but easier to use. And so this is with whole numbers. Oh, this is also one of my favorite apps. It's very simple, but very, very powerful. Okay, so we can create the 15. If we can duplicate with control. Control and drag like in Word. Okay, so how would we solve this? Actually, the same way. We want to, instead of separating the wholes from the fractions, separating the tens from the 5. So you got the idea. And separation. Add them up, and whatever. And also you could do the same thing. Okay. This would be the next level up with regard to abstraction. So we have 1,000 times -3. So a long click divides this, a long click here, long click here. And oops. For here we first have to mark 3, and then we can take it out. So again, very, very visual. We didn't invent this model, of course. It's used, but here it's digital in a very convenient way. Okay, quickly, vertical addition.
923.
What?
923.
What?
923 is answer.
So we have the algorithm and the visual. And so when we put this together, we get the 10, we take the 10 out and let go, it turns it to the 10. So the idea is that when we mark here the 1, it's not like technical, okay, the teacher said to put the 1. We see where the 1 came from. We see the 1 came from 10 units. Okay, then we could mark here the 3, put these together, okay, and then these become 100. And you got the idea. So for every question, every topic, we try to get the simplest possible way to do it. Okay, geometry. This is simply a convenient way to put, A, B, C. And you get the angle, which control the protractor, and bring it and just rotate. I'm not rotating. So it's just a convenient way to introduce the protractor in place. Okay, here we want the students to understand how many cubes there are. So we can separate layers like this. So if we just click now, it's very convenient to see. All right, so we have how many cubes in each level times the number of levels. Oh, you could do something in quantum levels of the electron.
No, it's the standard decomposition.
Well, this is easier. Okay. Yeah, and you can also do you can also do it in different ways. How many ways are there to do it? I guess 3. Yeah. Let's reset. And you can also add cubes, take out cubes, erase. Now, what if I want to add a cube over here? Solve it. Okay. Projection. I'll show you the projections. Maybe we'll give you some inspiration. Let's make this smaller. Okay, so the projections up, projections down helps give you the surface area. I don't know. Oh, by the way, I was creating some activity with the stuff, and I figured, and then I noticed that if you want to know the surface area, something like that, pretty sure, you count how many you see, whatever, and the answer will be what you see times 2. So it actually works. You simply count, multiply by 2. But we did not tell that to the teachers because it's a very idiotic way to solve it. So we don't want students to have idiotic ways to solve stuff. So we kept that as a secret. Okay, here's the area of a triangle. Okay, so it's a specific app specifically for this. So we can see this is half of the area. It's easy to see. You can also see here that's half of the area. So very, very specific app for a specific topic that's easy to use. These are the buttons of the app. Create new triangle, hide rectangle, stuff like that. And look what happens if I go out. Then it gives me a button that gives the triangles, these triangles that you can subtract to get the area. So it's really, really, really tailored for that specific thing. Okay, guess what's this for? Can you guess? Something else with triangles. What?
Quality.
What?
Equivalence.
Equivalence? No. Here, I'll click here, see what happens. And then try it again. Right? That's the height of a triangle. Okay, so it makes it very, very easy to see heights of triangles. Okay. What's this? You can't guess. Symmetry. Oh, symmetry. Okay. What shape has more symmetry lines?
Hexagon.
Okay. Hexagon. Well, in a way, that's correct because you meant that one. In another way, both of them are hexagons. Okay. We always get the answer at hexagon. So if we click here, we can see, double click. Here, see the symmetry line. And the symmetry line means it's a symmetry line because if we click here, it folds.
That we can use in all.
You can use that, right? All right. Okay. So here in class, the idea is that the teacher rotates and then the students have to stop it when they think it's a symmetrical line. It's a line of symmetry. Okay, so we can go over there. Of course, when you get to here, you already did that. So, okay. So here there are indeed more. We can also, I'll show the buttons. So it's possible also to do rotational symmetry. So here it rotates until it falls on itself. We don't know how we do spin half here. Okay. Yeah, so it's a nice symmetry, yeah. What?
Need to add the reps and then we have
What?
button. If you add reducible representations, we are going
Anyway, the parallelogram looks symmetrical, right? But it doesn't fold. Really does look symmetrical, but doesn't fold. Symmetry it has, of course, is rotational symmetry. Okay, so that's specifically for symmetry. All right, now we have all kinds of shapes we can rotate. This is the trickiest app to program because I programmed all of the apps yourself. So figured program 3D. I built everything from scratch. Okay, we can show the vertices. If you have kids, you can also do it with them if you want. So even for first grade, I mean, I just asked, I did an into their class and asked how many vertices are there. So so it's nice. You see different shapes. So the vertices or maybe edges, and ask how many edges, how many edges there are. And also color and count. Oh, let's give you something a little bit challenging. Okay. Example kind of shapes. Right now. Okay. Is this a net of a cube? Okay, is this a net of a cube? No, not enough, not enough, of course you don't have enough sides of it, just have 5 sides, so of course it won't. Okay, is this a net of a cube? Okay. How about this one? Is it a net of a cube? Oh, okay, let's check. Change your answer. And it is a net of a cube. So it's nice for the imagination. And every fold makes it easier to see. Is this a net of a cube? What do you think? Oh, okay, let's check. Fold. For the first thing you click turns into the ground, and the others fold. So yeah, it's not a net of a cube. Okay. So all kinds of shapes. By the way, there are 11. There are 11 nets. Turns out. Okay. Let's do all kinds of other shapes. So can you imagine what this will fold into? And the top. By the way, this is exactly the same thing. So 2 different nets, same folding. I don't know if that has a quantum analogy. Okay, what's this? What will this fold into?
Little house.
Yeah, yeah. Houses. Yeah, like those that got burned down. Okay, let's do one more. See if you can imagine what things will look like. What about this one? Imagine how this will fold. How it can be folded. Okay, so I'll start doing it. And as I do it, it will be easier to see. Okay. Also a house, different one. Okay, so nice stuff. Okay, so this is the oh, this is nice. This is this one. Oh, this one is, can you imagine this one?
Yeah, this is like.
Yeah, this folds nicely. And then what about this? Oh, this is like the Platonian shape, it's called. I mean, it's all triangles. Let's see. I think it should have a special name. They look a hedron or something? No. It just has 10. It's not that. 10 sides. Who played D&D? All right. So it's a 10-sided thing. Okay. Yeah, we also have cylinders. They just fold up. Okay. Yeah, so these were sort of different apps. We created like 150 of them for all different topics. Almost everything in the elementary school has something. Okay, next. And I invented games, so we created apps that are games. So sometimes there are math games that are simply, if you do the addition, you get points, right? Whatever. So here the math is integrated. It's a little bit more interesting. Okay. Oh no, yeah, okay. So here I gave one example of a game. It can be played in the mode of addition, multiplication, or fraction. So let's do multiplication. Okay, game. Maybe we'll do a game. Okay, new product. Okay, so I have to mark two hexagons that their product is 56. Okay, so yes. Okay, now the goal of the game is to have a sequence of your color from top to bottom or from left to right. Okay, oh, you know what, let's do boys versus girls. Okay. Okay, so blue boys. Okay, tell me, choose one of you. 42. Where do you want to do 42? Where? Right, left?
To the left.
Yeah.
No.
This
Like
one?
in the middle, like 6 and 7. Like this. Yeah.
This?
Yeah.
Okay. Girl, woman. Here, you give me one. Here. Too bad I don't have a wireless mouse. So you do or top to bottom or right to left. Where do you want your 42?
Bottom.
Here? Here? 6, 7 here?
Yeah.
Okay. Boy teams. Oh, that's good. You got 36, is good.
6 and 6 at the very bottom, like bottom right.
Here?
Talk about, yeah.
Really?
Yes.
No, 6 to right.
Diagonal up, the 6. Yeah, that one
okay.
goes to,
This?
yeah.
Yeah. So the students have to want to solve it, but you also have luck and strategy. So it's a very popular game in classes. So okay, 81. You want to try?
The 9 and 9.
Which ones?
Below.
This? These?
No, below.
This? This?
Yes.
These two? Okay.
36.
36.
6 and 6 at the top.
The top. All right.
Yeah.
Okay. So this is good. So you have another option also to try to go down here. So you open another option. Okay. 72.
Here, the 8 next to.
Which one? This?
Yeah.
Okay. Okay.
6 and 8 at a little top above the 6 and 7 that's highlighted. No, not that. Beside the 6 and 7. Yeah, this one. These
Here?
two. Yeah.
Why?
6 times 8 is what?
Continuous. That is not continuous.
You want to connect? You want to do
You
connect
wanna do
all the way
6 and-
this way,
Okay.
or connect down?
Okay.
So let's go down.
Okay. 6.
in the bottom.
What?
The bottom.
Yes.
These?
Right
Yeah,
on the bottom.
Yeah.
No, you can go even lower.
I don't have
No,
another
6,
eight.
6. Oh,
Yeah,
sorry,
so-
my bad eyesight.
Okay. So this could open another option, or you could do there and different ways things that could be okay. Okay, 72.
The red. I
What?
mean, the 9 and the 8.
Okay, which one? These?
No, in the middle.
These. Oh, these. Oh, this is good. So you kind of blocked off the blue, and you can win next turn if you're lucky. Okay. So the red went to the round, but now they're doing well. Okay. Okay, 54. You know the product, right? You know the
Okay,
96. That can help you.
Good luck.
What?
Yeah, we're gonna put that.
What?
So it's 6 and 9 below.
Where?
That follows from our 6 in the middle.
Yeah,
Here, these?
So
No,
right in the
no.
middle,
right in the middle.
Right in the middle?
where our blue is.
These?
No, towards the right,
To your right.
go to your
Oh,
right,
go further.
down.
Yeah, down.
Yeah.
Next to the
Yeah.
red.
Yeah.
This?
Yes.
Yeah.
How does that help you?
It's too hard.
Doesn't help you at all. You blocked it, going straight into the red.
Oh, it has to be this one.
It has to connect from top to bottom or from right to left.
It's-
So that doesn't really help you that much.
When I go to the 9 and 6 at the top.
So they think
Yeah,
they will
this could-
continue doing
Yeah,
this.
so this could help you connect right to left, okay?
Okay.
Now if red can win now. Okay, let's see if you
Yeah,
win.
exactly. We can't.
64, no, you're lucky. Okay, Reds, what do you wanna do? Open another option? Evan, you can do that, open another option and black the juice.
We can do those 8 and 8.
Yeah,
Where?
I'm thinking
Yeah, in the
about
left.
that.
Top here?
Yeah.
Yeah, good, so you block the blue and you also can win with 49 now.
Mm.
Okay, 49.
Oh, so the 7 and 7.
Okay,
Below.
here
Yeah.
or here, whatever.
No, the 7 and 7 that block red.
A bad person.
Okay, yeah. Okay, red, let's see if you win. 42.
Oh, they didn't.
Oh, it is.
You win. Yay. Very good. Okay. Okay. Okay, now in these apps, you can also, you saw I created pages and stuff. You can also save lessons. So a teacher can save a lesson for his class or share it with others, of course. Send it to students if he wants. Okay, so let's see an example lesson. Okay. Usually, I mean, almost always with our lessons won't be like straightforward, just do, we won't be, okay, do this, and then the student just does the algorithm. It's something more interesting. Okay, so. Okay, so what is the perimeter of the shape? Okay, let's see if we figure it out. And we have also an animation. So we go to turtles and animation. So this really helps students, even this simple animation, because students make a lot of strange mistakes. I mean, they count the squares outside, they count the squares inside, all kinds of stuff. So this animation is already nice. Okay, now here to make things a little bit more interesting, what we have here, this is the question. Okay, so this is 10. Okay, so without calculating, or use this result to figure out what the perimeter of the green shape is. So what do you think students could answer? This is the perimeter is 10. Now we have 2 of them. What's the perimeter? What?
Could say 20.
20.
20, okay. And what's the answer?
18.
Yeah, you won't say 19, right? A lot of students and also teachers think 19. Why? Because, hey, they're missing the middle. So it's nice to see like a lot of them think, okay, it's 19, it's 19. But then when this turtle gets to the end, they see 18. They get, what happened? Okay. And that's, we want the student to be in that situation. You want the students to be surprised. You don't want them to be, okay, I'll do that. What happened? So that's where you want the students to be. I'm sure that's in all levels, right? Also, if you're teaching whoever, you want some surprise. You don't want it to be predictable. And here in the next page, we can see why it's 18, because you lose 2 of them. And of course, it continues with different shapes, connected more shapes, they connected in different ways. And yeah, so these are prepared lessons. They also, when we have something like that, we also have a worksheet to do something interesting. Yeah, feedback from teachers who use it, and there are hundreds of schools in Israel who use it. And it's, yeah, let's see if you can let you hear it. See if that works. It's in Hebrew, but maybe you'll get the tone of voice. See if it works. Oh, never mind. You don't understand the Hebrew. Anyway, you can see what you're saying. You know, today during the training, I didn't have you. That's I call it nice math. Okay. With me, it's simply amazing. I feel I don't have hands without the apps. I don't understand how it's possible to do this without IC math. Once you get used to it, you don't know how to do any other way. Simply a gift. This is IC math. Okay, so it has a lot of potential. I mean, to be used very, very effectively in class. It's more fun, more engaging. Students remember more. Okay. So that's basically it. Our innovative interactive tools are revolutionizing math classrooms. And we're excited about the opportunity to bring IC math and its transformative approach to schools in the United States. I don't know if you're the exact correct audience for that, but hopefully somebody will see it. Empowering educators to deliver engaging and effective math lessons.
So, seeing stuff is really good, and I can show also after your talk when we're done how we can use it in quantum mechanics. So I have my examples like that. So is it all?
You know what? I'll just give you a little riddle. So you can think about, because I want to challenge you. I never had a situation where I didn't challenge anybody. So I'll leave you with a riddle. I'll create it. I'll just write it here on the page. Okay. So, question for you is this: you have this shape and another shape. Okay, two of them. Okay. Now, your task is to combine them, like one next to each other. I mean, don't put one on top of each other, next to each other, and create a shape that with a perimeter of 16 and 2 symmetry lines. Okay, that's the task. You want to try, because I want you to have some challenge. Okay, try to create a shape. Okay, and with these two together, perimeter of 16 and 2 symmetry lines. And if you have some insight, you can share it. Like what kind of, how do you translate that the question to other restraints that can help you think about the problem? Of course, you can rotate the shapes and stuff. Okay. Like this. I think you need to write.
I think putting this one and then translate.
So we can
keep upside down.
Right. You need to
Yes.
give it four lines. Okay.
I'm gonna do it. 6.
to get rid of the lines, you need to kind of rotate and put them like that.
You need touching at 2 segments. 2 segments must touch. Right. How do you get 2 segments to touch? Okay, so in class, that would be the discussion. What?
Corners. Put one to stick in the corner.
How? Like this?
No, oh yeah, something like that.
Yeah, but this, I don't think this doesn't work.
Yeah, well, maybe to the up.
Just rotate it 180.
How, what?
Rotate it 180 and
Okay, I'll,
Rotate it, yeah.
Rotate 100. Yes,
yeah,
exactly.
what do you do now?
and connect by
okay.
button.
And then maybe if we join by translate.
Where? How?
So, need to have freelance touch.
Yeah. So how do you, does this
Sorry,
work?
it is. If we do
What?
I like just under the bottom.
Here,
That's,
that,
that
becomes,
loses 6 though.
because that becomes 14.
Just put it one brick bottom and two brick left.
What, like this?
Yeah, yeah, like
Like
this.
this?
I think there might be symmetry. One diagonal and another
Yeah,
diagonal.
this is
Yeah.
14.
Yeah. Yeah, so we have two symmetry lines, 1 and 2. So the tricky thing is it's like a diagonal. You don't think about that. Okay, so thank you very much.
Very good. Let me show you my puzzle.
Good. So I'll stop sharing.
Let me share screen.
Your challenge back.
Here is a, you're familiar with the concept of eigenstates of operators?
Yeah.
Okay, so this illustrates eigenstate properties.
Size, directionality.
So one of them is not eigenstate, so we need to find out which one is not an eigenstate.
Whoa.
This is operator, so basically operator acts on a cat.
I think here, this is.
Yes! So that's what's the good one to look at. Yeah, but the idea of visualizing things, operations, and numbers,